Hi guys, let's continue to charge on with the new chapter this week on pressure. Okay, for this question, it is, let's start with this on density. Now, first of all, in this question, they said 35 grams of liquid Z is poured into this cylinder that has originally 56 grams of paraffin. The density given is 0.8. Okay, so what is the volume of the paraffin? You can immediately count for the volume first. Volume is mass divided by density, because density is mass divided by volume, right? Mass is 56, density is 0.8. So this is 70 cm cube. This is 70 cm cube. But the total substance volume is 90 cm cube, according to the question. So it means this liquid Z has volume 90 minus 70, right? 70, 90 is the complete one. 70 is from the paraffin. So the liquid Z has volume 20 cm cube. All right, so how to find the density of the liquid Z? Very simple, it's mass per unit volume. The mass is what? The mass is 35 grams. Volume is 20, so you get answer as 1.8D. Let's take a look at the second question. This is from Anglican High. All right, basically you press a pedal here. You're compressing the fluid inside this part. All this inside here got fluid. They exert a pressure on the fluid. The fluid are exerting pressure on each other from here until they transmit to exert pressure on this brick pad. Okay, so along here they have the same pressure. The reason is they are at the same level. So remember, to do pressure question, you have two very important concepts. Same level must be same pressure. The first concept. The second concept is pressure at that point is due to everything on top. Don't forget that, huh? Got two basic concepts here. First, same level, same pressure. Second is pressure at a point is due to everything on top. We'll see a lot of those kind of questions at the back, okay? So for this case, let's take a look how to solve this question. So pressure 1 is pressure acting on this master piston. Pressure 2 is pressure acting on this brick pad. So pressure is what? Force per unit area, right? So what is the force? 450. Okay, 450, the brake applied on the force applied on the master piston, right? So 450 divided by 1, because they said the area of the slave is 4 times that of the master. This is a slave, this is a master. This area is 4, this area is 1. So area is 1, area is 4. So how to find the force acting on the slave? Just do the math, you will get 1,800. Answer is D. Let's take a look at the third question from the Anglican High as well. Now, for this one, you need to understand this is a manometer. For a manometer, you need to deal with the two concepts I mentioned just now. So it's very important for you to identify the levels for you to analyze. Which is the level that you should analyze? You should analyze the lower. This is the lower level, this is high level, right? We always analyze the lower level. Please take note. Okay, so you draw one line here. This is the lower level. Oh, then we say, what is the pressure at this point? What is the pressure at this point? Do you know this shear pressure of the gas? All these are the gas. This point, what is on top of this point? Gas. So pressure at this point is pressure of the gas. This point have the same level at this point, right? So they have the same pressure. So what is the pressure at this point? What is everything on top of this point? Remember, pressure at the point is due to everything on top. It must be due to the fluid here, which is pressure due to the water, plus the atmosphere here, pressure due to the atmosphere. So in other words, this is due to pressure due to the water plus pressure due to the atmosphere, equivalent to pressure of the gas. That's what I shown here, okay? Pressure of the gas here equal to the atmospheric pressure plus the pressure of the water. What is atmospheric pressure? The question says 76 cm mercury. Pressure of the water is how many cm? This 40 minus 10, so it's 30 cm of water, right? So you need to convert all to Pascal using what? Using rho GH. So 76 cm mercury means the H is 76 cm. You must convert to meter, right? So, but it's in mercury, so you must use density of mercury 13,600. G is 10. H is 0.76. Must convert to meter, yeah? 30 cm water. What is the rho GH for water? Rho is what? Rho is 1,000. It's the density of the water. G is 10. Height is 0.3. Okay, 30 cm 0.3. So add together, you get 106360. Answer is C. Let's move on to the next question from Crescent Girl. This question is talking about two barometer. That is one inverted. This is the inverted barometer. This one has trapped air. This one, the air is here. This one is mercury on top. This one is mercury below. You know, why the mercury never fall down? Have you ever thought of it? Why? That is the very important thing you need to understand. Okay, so how do you do that? How do we do this question? Which statement is the correct explanation? They say X is shorter than Y. What does that mean? And they ask you why. The answer is C, but why? Now let's take a look. Take analysis at this level and take analysis at this level. So at this level, what is the pressure at this point? The pressure at this point is pressure of the rho GH of the mercury plus the atmospheric pressure, right? That's what we have this formula, okay? Because pressure at this point is due to everything on top. What is on top? Mercury plus atmospheric pressure. So we get this formula, okay? What about this inverted tube? We do this at this point here. Why we do here? Because this one, we know the pressure at this point. Because this point is exposed to atmosphere, right? So there will be upward atmospheric pressure acting at this point. This atmospheric pressure is responsible to push the mercury and the air out so that the mercury never fall down. That's the reason why the mercury never fall down. Okay. But then we also learned that pressure here is due to everything on top, right? What is on top at this point? The mercury pressure and the trapped air pressure, right? That's why atmospheric pressure at this point, atmospheric pressure equivalent to rho GH of the mercury plus the pressure of the air. So tell me, which pressure is higher? Obviously, this pressure of the air is ATM plus rho GH. This pressure of the air is ATM minus rho GH. So which one has highest pressure? Obviously, this one has higher pressure, right? And do you still remember when higher pressure, press on this point, the volume will be lesser. The volume will be lesser when the pressure is high. Okay? So that's why pressure of trapped air in M is larger. That's what we can deduce from this question. Okay? Next, we handle a structured question from Anderson. So for this case, they ask you, calculate the pressure at the bottom of the liquid, this point. They ask you, what is the pressure at this point? So how to do? Same thing again. Pressure at this point is due to everything on top add up. So what is on top? On top we have the fluid, right? Plus the atmospheric pressure. So you must use rho GH plus atmospheric pressure because on top you still got atmosphere, right? Yeah, at this point you got liquid, you plus the atmosphere, so add together. That's why we have this formula, atmospheric pressure plus rho GH. Atmospheric pressure is 1 times 10 power 5. Rho is 1.6 times 10 power 4. The question said, yeah, it's here, right? This is the, you see, this is the atmospheric pressure, the liquid, right? The density of the liquid. G stand height is 1 because this is just 1 meter height, right? In meter. So that's why we get this answer. All right, 2.6 times 10 power 5. Next, they ask you, what is the force exerted at this point? And you know that pressure is force per unit area. So force must be pressure times area. Pressure times area. Pressure is found already just now times the area. What is the area at the bottom? 4 times 10 power minus 4, right? This is the base area. So that's why we get answer as 100 Newton. Next. Wow. Now you invert the tube. You invert the tube, right? Then you put like this. You put like this. You use a sheet of glass to cover it, right? Now they ask, what will happen if the glass is removed? Guess, what do you think will happen? Obviously, when you remove it, the mercury will fall down. The liquid here will fall down, right? Why? Because the pressure here is bigger than the atmospheric pressure. Do you understand? This bigger than the atmospheric pressure. You see, just now, what is the pressure at this point? Is rho GH plus atmospheric pressure, right? Correct or not? So this point has pressure higher than atmospheric pressure. So now you cover it, then you invert it. So obviously this point will have higher than atmospheric pressure. It's the same pressure like just now, right? Higher than atmospheric pressure. So when you remove it, the liquid will start to fall. Yeah, that's why it's going on. So you say pressure of the liquid inside the tube is greater than atmospheric pressure. You get 1 mark. Next, you need to say liquid in the tube falls. 2nd mark. After that, it stopped falling and maintain a certain height when pressure of the liquid inside tube equals to atmospheric pressure. So remember, if this is mercury, they will stop at around 76 cm, right? Correct, because 76 cm mercury represents atmospheric pressure. That's the reason. All right. Okay. Write down this. Okay. Let's move on to the next question. So this is, isn't it look like the same? You know, this is another manometer question. For this manometer question, we again need to choose the lower level. This is a lower level, this is a higher level, right? We must choose the lower level as our analysis. So we need to extend this lower level here. Now, so this is a pressure, let's call it Q, let's call it R. Pressure at Q will be equal to pressure at R, right? Okay. So what is pressure at Q? Pressure at Q is due to the gas. You know, can you see that it's due to the gas? Yeah, so pressure at Q is the gas. Okay. Then what is the pressure at R? Is due to rho GH plus atmospheric pressure, right? Rho GH plus the atmospheric pressure. Okay, that is the relationship you must come in your mind immediately before I even see what they're asking. Okay, they say, what is the pressure in the gas? Oh, yeah, they're asking you to find this pressure of the gas, right? So you just use rho GH plus atmospheric pressure like this. Okay, atmospheric pressure is 76 cm mercury. Rho GH is what? What is the cm? The cm, how many cm mercury? 32 minus 15, right? So add together, the total pressure will be 93 cm mercury, but 93 cm mercury is not in Pascal. You need to convert it to Pascal. So rho of the mercury, G is 10, height, you must convert to meters times, divided by 100, right? So it's 0.93. So that's the answer, 126000. Okay. Now, the next one is a bit difficult. They ask you the gas pressure exerted on the rubber bung equal to the gas pressure exerted on the wall of the container. Yeah, they said the rubber bung, they said this part, the pressure exerted on this part equal to the pressure acting on the wall of the container. They ask why. So how are you going to answer this question? You know, what is the meaning of pressure? Pressure is force per unit area. Okay, force per unit area. You need to mention at least this. They have the same force per unit area, but doing like this is not enough. You need to go zoom into the molecules level. So this is how you should write. You say that number of molecules per unit volume is equal. Okay, number of molecules per unit volume, it means what? It means, for example, this one has one molecule for this surface area. This one also, for the same area, they also have one molecules bombarded. Okay, that's the meaning of number of molecules per unit area. How many number hitting the surface area? Okay. You must say frequency of collision of molecules per unit area are the same. Because if you recall what we have learned in the thermophysics, pressure means what? Pressure means frequency of collision with wall. Frequency of collision. Okay, this is another keyword. If you're my student, you should have learned this already. Okay. Yeah, so I hope you learn this in school also if you're new. Okay. Now, frequency of collision of molecules per unit area are the same. Please write down all these things. They're all very important stuff. Exerting equal force per unit area, because I said already, pressure is force per unit area, right? They ask you why they're equal. You must mention because they are both equal. They both have equal force per unit area. Then you will get the third mark. See, first you must focus on the molecules per unit volume. Then you need to talk about frequency of collisions. Then you relate to pressure as force per unit area. These 3 points. Okay, I hope you got it. And lastly, they said, a physics student notices that small increases in pressure are not noticeable. Why? Because you need to understand pressure equal to rho GH. The density of the mercury is super high, you know. You increase the pressure by a little bit, the height will not rise a lot, right? The height only rise a little bit. You cannot even notice the increase of height. But if you increase the pressure by a little bit, and you want height to be noticeable, you want it to be noticeable, means the height must shoot up very high, right? So what you should do, you must change the fluid to become what? To become lower density. Okay, because the pressure remain constant. Okay, the pressure remain constant, right? Now you want the reading to be noticeable, means the height will be increased a lot. You must decrease the density. In other words, now you cannot use mercury anymore. If you use water, let's say, water is very, very less dense. Okay, then if you apply increase of pressure, the height of the water will shoot up rapidly. Then it's very, very noticeable. Okay, that's why you need to write, use liquid of smaller density. Since pressure difference remain constant, this pressure difference no change, one always constant, right? Yeah, using rho GH, smaller density result in greater height. Greater height, this is actually a keyword, so I shall underline this. A greater height. Okay, that is the idea.